Hi guys, I'm back. This time we're going to talk about extreme weather. So this is the content that is in the last section of chapter 5, which is called violent weather. And it's going to talk about some of the more extreme weather phenomenon that occur on our planet. So I'm going to switch so that you guys can see the screen. And you won't have to look at me. Share. Okay, so the first kind of violent weather that it talks about are hurricanes, and we have mentioned hurricanes in here a bit already. Hurricanes occur around extremely low pressure zones because we've learned that air moves down gradient from high to low pressure zones. And hopefully you remember that a hurricane and other low pressure zones are also called cyclones as opposed to anticyclones, which are high pressure zones. And a storm where a bunch of moisture and other air is coming in to a low pressure zone becomes considered a hurricane at the point that the wind speeds reach 75 miles an hour and the storm center is 100 miles across, or the storm itself, I should say, not necessarily a storm center, is 100 miles across. So these are pretty big storms. We can view them through satellites, like this picture on the bottom left, from space, where we can see all the clouds that are forming around this low pressure zone. And hurricanes in particular are low pressure zones and storms that develop in the oceans. And in particular, they develop over low latitude ocean areas where the high incidence of solar radiation causes the ocean temperatures to be very hot. And it's in the hottest time of year that these storms form. So when is the hottest time of year? You guessed it, it's the late summer. So hurricane season is kind of July through November. So kind of the late summer and early fall when the sun has been beating down over the ocean. The ocean has been absorbing lots of energy for several months. And it's at that point that the air over the ocean gets hot enough that it starts rising off the ocean and creating a pocket of low pressure near the surface. Then air rushes into that low pressure zone and it doesn't move straight in, but it curves, it swirls around as it collides in that center zone because of the Coriolis effect that we've talked about before. So storms spin in a predictable direction in the northern hemisphere. As winds bend to the right, they create these counterclockwise spinning storm cells. And in the southern hemisphere, winds bend to the left and create these clockwise spinning storm cells. And then we also have mentioned before that hurricanes do not cross the equator, which is pretty interesting. The winds are consistently colliding along the equator. The way that the rotational velocity of the Earth works basically just prevents these storms from moving across. So the picture on the right is showing the storms basically being trapped in whatever hemisphere they begin in. Okay, so what happens during a hurricane? Well, basically air that's very humid because it's been hanging out over the hot ocean for a period of months. And we know evaporation is higher when it's hot in the air and hot in the water. That hot air starts to get sucked upwards because hot air rises, right? That's that convective uplift process that we talked about last time. And then the same kind of series of cascading effects happens that we talked about in the context of condensation and precipitation. But rising air experiences adiabatic cooling, lower pressure at elevation cools the air, then the water holding capacity drops, and so air starts to condense. And if there's enough water droplets, then that condensation will start to fall as precipitation. So hurricanes are associated with high wind speeds as air rushes into the low pressure zones, but they're also associated with a lot of rainfall as all this condensation is happening with rising air. So we also have learned that condensation is a process that releases energy to its environment. So once these storm cells get started, they kind of experience a positive feedback, right? A process where once a process gets started, it kind of feeds on itself and becomes more and more exaggerated over time. So the condensation actually warms up the air a little bit, which causes more convective uplift. And then the uplift creates the adiabatic cooling, condensation and precipitation on elevation, and that actually warms the lower air mass a little bit. And then it kind of snowballs or hurricanes on itself as the storm gets bigger and bigger. Again, positive feedback. So right at the center of the storm, that's called the eye of the storm, you may know that there's this kind of eerie phenomenon where there's no wind, it's very still, it's very calm, there's no rain. And this is kind of this bizarre location right at the center of the storm where the force between all the converging winds is totally balanced. And so there's very little horizontal wind speed across this location. And in some cases, we actually have descending air that has risen around the spiral, around the eye, that's actually coming downwards through the center of the storm in the storm's eye. And I'll post a little video clip showing this kind of eerie experience of watching the storm come in and then experiencing the eye and then watching the other side of the storm go by afterwards. So we also mentioned that this kind of phenomenon happens right along the equator a little bit, and there's actually very little horizontal wind across the equator, even though there's a lot of vertical air motion along the equator. And again, that's because the winds that are converging there are very well balanced against one another. So hurricanes, which are also sometimes called cyclones, also sometimes called typhoons, depending on the part of the world where they occur, they're very destructive, but fortunately, these storms are essentially fed by all this evaporation and condensation that's occurring over the warm ocean. And so as the storms make landfall, they actually lose their steam, they lose their energy source, and they start to slow down. So upon first contact, they can be very destructive. Here's a picture of Typhoon Haiyan that happened back in 2013, and it is the storm that has the highest recorded wind speed at landfall, which was 195 miles per hour. It's just truly unimaginable, and you can see how much devastation it did to that community in the Philippines. But we've also seen, of course, hurricanes here in the United States do a lot of damage as well. But again, I'd like to emphasize that usually after 20 miles of movement away from the coastline, the storm will really start to lose its energy source and will start to die out. So it can definitely do destruction along the coast, but you don't really read a lot of information about hurricane devastation that happens in Tennessee, right? You hear about hurricane devastation that happens in Florida or in North Carolina, places that are right along the coast. So hurricanes can have a variety of categories that are determined depending on the wind speed of the hurricane, and you do not need to know these specific wind speeds for my class, but you might be interested to see. So first of all, on the scale, we can see that the category of a storm is first called TD, or a tropical depression, right? Meaning there's a depressed atmospheric pressure, low pressure zone, which can create a cyclone or a storm. And then it turns into a tropical storm, which is a lower pressure, creating a lower intensity of wind being pulled in, more upward motion, more convective uplift, more condensation, more precipitation. And then at the point that the storm picks up to 74 miles per hour, and again, as we said before, it gets 100 miles across, we call it a Category 1 hurricane. And then when it gets 96 miles an hour wind speed, Category 2, and then all the way up to Category 5, which is over 157 miles per hour wind speed, which again could be really, truly a devastating event. So in the United States, we are no stranger to hurricanes. We do not have many hurricanes on the West Coast and in California, because as we've learned in this part of the world, we have a lot of winds, or I should say in the tropical warm part of the world where hurricanes happen, the winds are usually moving from east to west. And so we have hurricanes that hit in the southern United States where the water is warm enough, and in the zone where trade winds are moving storms across the Atlantic and slamming them into North America, right? In the Pacific Ocean, the storms move across the ocean away from us towards Asia, where they create typhoons. But the Atlantic Ocean is definitely home to lots of hurricanes. And 2007, a recent year, is one of the worst hurricane seasons that we had on record. It was bad in terms of the intensity of the storms, the frequency of the storms, but also in terms of the devastation that was created by the storms. So in 2017 in the United States, we had 6 landfall events by Category 5 storms. And in some cases, it was the same storm, like Hurricane Maria, that hit various places, like hit Puerto Rico and hit Cuba. I guess Cuba's not the United States, and hit Florida. So these are just kind of some of the pictures of these intense storms. And obviously these are not visible light photographs. These are infrared energy photographs showing moisture in the storms moving around the eye. As we get warmer and warmer air temperatures and ocean temperatures on our planet, there's a lot of concern that this will increase the rate of hurricanes that we see on our planet. And that makes a lot of sense if we understand why hurricanes form and that they form in these warm ocean conditions. We already have seen that there has been an increase, and so we do expect that this trend will continue. And for example, 10 of the 20 most active hurricane seasons that we have in recorded history, so for the past about 120 years, have occurred just in the last 20 years. So this is definitely a trend that's picking up. And this is a satellite image, a visual light image showing the storms. And let's see, it shows Tropical Storm Katia, Hurricane Irma, and Tropical Storm Jose, which eventually became Hurricane Jose, all traveling across the Atlantic Ocean. And all of these storms collided with the Caribbean and with parts of the United States to do lots of damage during the 2017 hurricane season. And it's pretty unprecedented to have 3 major storms moving all at once, right, within the same period of weeks, colliding with the same kinds of communities. This is definitely an extreme kind of hurricane phenomenon. Hurricane Maria was one of these 2017 hurricanes that came in just after those storms that were pictured in the last slide. So after communities had already been devastated by intense rain and wind, Hurricane Maria came a couple weeks later and did an extreme amount of devastation, in particular to places like Puerto Rico, which you probably heard about in the news at the time. And Puerto Rico, as you hopefully know, is part of the United States, and the people that live in Puerto Rico are United States citizens, even though it's considered a territory, not a state. But basically there was this enormous devastation that occurred essentially on US soil in Puerto Rico, and 80% of the island was without power for several months. So if you have complained about being out of power for a number of days before or hours before, it's important to remember basically, you know, the convenience that we're accustomed to and how really truly devastating it could be to find yourself without power for such a long period of time. And of course, there was a lot of controversy about how this situation was handled, both by the US government and by some of the local Puerto Rican government. But nonetheless, this was a very devastating storm that impacted a lot of US citizens in the last few years. Okay, so the next topic that I want to mention is thunder and lightning. So thunder and lightning often occurs during storms like hurricanes and tornadoes that we'll talk about next, but sometimes can occur independently. Probably a lot of us who live in places like California have seen thunder and lightning before, even though we have not experienced hurricanes and tornadoes. And essentially, this process is created as friction builds up between the air or the ice particles that are in the air. And as air is convectively rising, moving upwards, the ice crystals that are in the air rub against each other and they build up static electricity. So that's why sometimes before a big thunderstorm, you'll see that your hair is kind of standing on edge. That's kind of in response to the static electricity that's building up through all this friction. And what happens is there's a buildup of distribution of charges within the clouds where we actually have more electrons and negative charges concentrated in the lower parts of clouds and then positive charges accumulating in the upper parts of clouds. The ground surface also tends to have an overall net positive charge relative to the lower parts of the clouds. And then the lightning happens when there's a very quick movement of electrical energy through this kind of electron transfer movement between areas of positive and negative charges to balance out these charges. So the lightning bolts can happen between the upper and lower parts of the clouds to balance the energy there. And they can also happen between the lower parts of the clouds and the ground to balance the energy differential there. And when this energy moves, it happens very, very, very quickly to create a lightning bolt that's extremely hot. A lightning bolt have been measured to be over 45,000 degrees Fahrenheit. And it's this really hot temperature that causes air to rapidly expand around the lightning bolt. As that air rapidly expands, it basically breaks the sound barrier and creates a big sonic boom or shock wave that we hear as thunder. So the thunder always comes after the lightning. And as you probably know, you can basically judge how close you are to the lightning strike by listening to the timing of the thunder relative to the lightning. So when you're close by, the thunder, the sound that moves slower than the light will come in pretty rapid succession after the light. And if you're farther away, since the sound moves more slowly, it will take a longer time for that sound to catch up with the light, and you will see the light quite a bit before the sound gets to you. So that's kind of an interesting thing. Another thing that you might not know is that usually when lightning strikes happen between both the upper and lower parts of the cloud and between the cloud and the ground, it appears to us as one long lightning strike because it happens so fast, but it's actually usually two parts where there's some electricity that we can see moving up from the ground and down from the cloud that meet each other. And then the same thing, it would kind of have two parts in the cloud. So I'll include a little video clip for you guys to observe that. So anyway, that is a type of extreme weather phenomenon. And of course, getting struck by lightning is not something that you want to do. It can impart an enormous amount of energy on you and often might kill you. So be careful. Be careful when there's thunder and lightning out there. Okay, the last section of this chapter talks about tornadoes, and tornadoes are kind of a land-based equivalent of the ocean-based hurricanes that we talked about earlier. So they're also created when we have these extremely low pressure zones that happen when air starts to rise rapidly off the land surface, creating a low pressure zone, and then surrounding air rushes in to fill in that low pressure vacuum. Air spins around the low pressure zone, creating a cyclone, same as the hurricane. But in this case, the air is much, much drier, so there's not nearly as much condensation that happens in the air. And so we don't see these same huge cloud, circles, cyclones around the center of the storm as we do in the oceanic hurricane systems. But besides that, similar processes happen. Rising air can create friction, and it can create thunderstorms with thunder and lightning. It can also create precipitation, but just usually not as much precipitation as we would see in humid hurricane systems. The funnel at the center of the tornado is a kind of equivalent to like the eye of the hurricane, except it's a little tighter, it's a little bit smaller, but that's kind of the exact point where the low pressure is existing and that the air is coming in to swirl around that low pressure zone. Hurricanes can have extremely high wind speeds, up to 165 miles an hour, which is terrifying, and which is why they can do lots of damage in places while they occur. They occur a lot in the U.S. Midwest. That area, including places like Oklahoma, Kansas, is sometimes known as Hurricane Alley, right? Not the kind of place where you necessarily, or sorry, Tornado Alley, not the kind of place where you necessarily want to be during tornado season. And what we do know is that one of the reasons why we have a lot of hurricanes there, or sorry, tornadoes there, is because there's basically wide open flat space with not a lot of obstacles. The air is moving up and over. So winds can pick up high wind speeds. Also, we know that there's kind of a convergence, a mixing of more tropical and then more Arctic air in this part of the world. And so there's this kind of frontal uplift that happens. And when the conditions are just right, that frontal uplift can happen very precipitously or very extremely to create these really, really fast uplift speeds that create extremely low pressure zones. But beyond that, these systems are actually not well understood. I've tried to do a lot of reading about tornadoes because I often get questions from students. And what I have learned is that even people that are experts in this really admit that there's a lot about when and where a tornado will form and why exactly a tornado will form in one place and not another, that is actually really still not understood by meteorologists and other weather scientists. So beware, if you live in a place where this kind of thing can happen, you would be familiar that this kind of thing can be quite devastating. But this is not the kind of thing that we would expect to see in California because we really don't have the conditions that would create this dramatic uplift speeds. Okay, that's all, folks. Take care.